Okay, this is Mr. Peterson. I teach mathematics at Gardner Edgerton High School in Gardner, Kansas. And this is a second of a two-part series on solving systems of equations with three variables. So I recommend that you look at part one before you come to this video. And the difference here is that I'm going to show you how to organize your work on note paper this time. So you see the background is meant to emulate note paper. Okay, so the original system will be given to you in this format, and I'm going to suggest that you label the equations A, B, and C. Then, once you've done that, you're going to pair up A and B and pair up A and C. So those pairs, and your goal here is to eliminate the value of X. Give me a second to set up my pen here. You're going to eliminate X from both pairs. Now in the first pair, where we have this 2x and this 4x, our least common multiple of those numbers is actually 4x. So we want a 4x on the top line, and to cancel it, we want a negative 4x on the bottom line. I realize that you might switch those, but I just always do it with a positive 1 on top. Okay, so to make that top line into a 4x, so we'll take the 2x and we'll double that whole line to get the front to work. And distributing gives 2x. We've already 2 times 2x becomes 4x, and then plus 6y, and then minus 2z, and then finally to balance it, you have to multiply the other side also. So we get a 2 over there. Okay, the bottom line is almost good to go. We're going to multiply it by negative 1 down here, which has a simple effect of changing all the signs. So you're going to see I'm just going to change all the signs across that bottom. Okay, then we add these lines, and that eliminates the x. Now we basically repeat the process on the other side with the other pair of equations. This time 2 and 3 have a common multiple of 6. So we want a 6x and its opposite. Later that'll cancel. That's what we're trying to do. We're trying to cancel that. And to make the top one into a 6x, you have to triple the line. So I'll be multiplying everything by 3. And on the bottom line, we're going to multiply everything by 2, which when you distribute gives the negative 6x like we're hoping, plus 4y plus 12z, and that equals negative 4. Okay, when you add these lines, you get 13y plus 9z, and over here negative 1. Okay, I label these intermediate results star and double star, and we now have two equations with two variables. Write one underneath the other. I'll bring that double star one over here. Line everything up. And now we're going to eliminate the y. The least common multiple of 5 and 13 is 5 times 13. That would be 165, I think, but maybe not. Let's see, 13 times 5. Oops, I'm wrong. It's 65. Okay, our goal is to get 65y here. Oops, 65y and negative 65y. The top line has to be multiplied by 13. And that would give me 39z here. And 13 times 1 on the other side is 13. Don't forget you have to balance the equation. You're actually multiplying both sides, although I didn't write it that way. And on this one, to get my negative 65, I have to multiply everything by negative 5. Okay, we're going to add these lines here, and when we do, it cancels the y, and you're left with negative 6z equals 18, dividing by negative 6 here, and we've got our first result. Z has to be the value negative 3. Okay, so now we're going to bring this over here and put that new information into the double star equation. 13y plus 9 times negative 3 equals negative 1. 13y minus 27 equals negative 1. Adding 27 to both sides takes us down to 13y equals 26. Dividing by 13 would tell us that y is equal to 2. Okay, we are significantly down the road here. We got 2 out of the 3 answers here. So we're just going to take that y value we just found and the z value we found earlier, and I make my students plug it into equation A. So we're going to take, and where it says y, we're going to put that 2 we found, and minus the z value. This is a little tricky. It's a negative 3. So we've got a double negative going on there. So let me simplify this a little bit here. It's going to be plus 6 and then plus 3. So that's 9. 2x plus 9 equals 1. Subtracting 9 gives negative 8. And dividing by 2 gives our last answer of negative 4. Okay, so we have our answers, or we have all 3 of them. So let's go ahead and write them. It's negative 4 for the x, 2 for the y, and z is negative 3. Please notice that's the reverse order we found them in, and we'll circle that. The only thing left here would be to check it, and I usually make my students check it in equation C, so I'm going to go ahead and copy that and see if it works here. Negative 3x, I'm copying down C here, plus 2y plus 6z is supposed to equal negative 2, and let's plug all 3 numbers in and see if it works here. Negative 3 times negative 4, I'll go ahead and put 12 down below there, plus 2 times the value of 2, which is y, and that's plus 4, and then plus 6 times negative 3, which would be minus 18, and it's supposed to add up to negative 2. So let's see what we got here. This is 16 minus 18, it gives negative 2. So we do have the right answer. Now you can see that I filled up a whole page here. And organizing your work is really important. The other thing would be to work very methodically. But let me just discuss the overall overview of this. I paired the A and the B, and then over here the A and the C. And in both cases, you want this x to cancel off and this x to cancel off. And that'll take you down to the star and double star. Then you take your double star equation and bring it underneath the other one and work that out, getting rid of the y, and you'll be able to find z. And it clears the page here to come over and substitute into that double star equation the z value that you found earlier. That'll lead you to the y, and then you just take the y and the z and plug it into A. The rest of it's just formatting and checking. And usually I don't check it in I don't check it in all 3 of them. I just check it in one of the ones I haven't used recently. In this case, equation C is the one I used to check it. Okay, so I hope this helps you. In conjunction with the other video, I think you'll have enough to do these problems. There are some curveball problems where things are different, but I'm not dealing with them in these first 2 videos. And I hope it helps you.